In this video, we're going to look at the mosaicing processor in RAMP. So the mosaicing processor allows you to take two or more rasters and merge them together. Now those rasters may overlap each other, or they may be side by side or adjacent to each other, but nonetheless we can take them and create one new raster based on the combination of those two or more input rasters. So if I double click on the mosaicing processor, you'll see there are just two methods in it currently. And we'll look at each of these methods in a second. But first, let's look at the input data sets that I'm using as an example to show you how these Mosaic processor methods actually work. So the first is the Australian topographic and bathymetric data set. This is a coarse resolution data set provided at 250 meter resolution. The coordinate system is WS84 geographicals. The height values are relative to mean sea level in meters. So I'm actually going to just choose a different way of rendering this for the sake of it. I'm going to choose the terrain renderer color palette. So this is specifically for topography. Okay, and let's render that. That's better. Look at that. Okay. Now, the other data set I have, so this one's quite coarse. The other data set I have is from Geoscience Australia, and it's a multi-beam echo sounder data set, so it has much higher resolution than the coarse model. But you'll notice that this data set has some null values in it. And what I want to do is specify an area of interest in here, and then fill in the null values with the coarse data set from the 250 meter data set from Geoscience Australia. So let's just window in on my area of interest. I'm going to choose this. Let's render that. Okay, this is my area of interest, and now I'm going to clip the coarse model to the extent of my new area of interest. So to do that, I'm going to use the geometric transforms, clip raster to the extent of another, choose my coarse topo, and my extent raster will be the one that I've just clipped out of the multi-beam. Click OK and render. Okay, so these are my two data sets, the high resolution multi-beam data set and the lower resolution Geoscience Australia bathymetric data set. So let's look at how we will mosaic these two together now and what the options are for that. So I'm going to double click on the Mosaic processor. The first method in here is Mosaic in-memory rasters. That's exactly what I want to do. So I'm going to choose my two. Actually, before I need to do this, I need to check the resolution of the high-res data set. Okay, it's here, 0.00463, blah, 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 blah. This is in decimal degrees because the multi-beam data set is also WS84 geographical. Whilst I'm here, I should also check a couple of other things. The values are negative, that's good, and in my coarse data set, the values I can see here are also negative, good. Okay, so we don't need to invert the sign of the values to make the two compatible. Okay, let's go back to the mosaicing processor, mosaic in-memory rasters method, pick these two rasters, it's that one and that one that I want to mosaic together. And then I have a couple of options. The options for merging them together are simply take the value of whichever one has the smallest or minimum value, take the maximum value, take the moving mean, and in this case the moving mean is actually going to be the same as the true mean because of the way the algorithm works. So that's just a real mean. Replace essentially means take the last value that was added to the output. So the value of the last raster that was added to the output, and use that as the output raster value. And then I can do sum and count, which are fairly meaningless in the context of mosaicing. So what I'm going to do is I'm going to choose moving mean, and in my case the moving mean is the same as the true mean. So I'll go OK. And my output cell size I'm going to put as the cell size of the highest resolution raster, the multi-beam raster. All right, let's do this and see what happens. Okay, it's Mosaic the two together. Let's render it and see what it looks like. Okay, you can kind of see a little bit of an artifact here where perhaps the two data sets haven't merged quite correctly, so there may be some leveling issues with the two rasters. This was the high-res raster, this was the low-res raster, and here you can see kind of the artifacts of the high-res being overlaid on the low-res. Let's put a profile through this and see what that looks like. And as expected, you can see that as it crosses over into the high res raster, the level drops down and it goes back to the low resolution raster, then the high resolution, then the low resolution. So indeed, there are some leveling and offset issues between the two raster data sets. One of the things that we want to build into one of the future versions of or releases of RAMP is a more intelligent blending algorithm for mosaicing that allows you to specify the relative horizontal value and temporal uncertainties of each of the input rasters to give a better blended approximation of the output. So that's something to keep an eye out on for the future. But for the time being, this is the best that we're going to get, given that these two data sets are not leveled out correctly or perfectly. And that's to be expected. Okay, let's look at another way of specifying the output. Okay, so the method I wanted to look at this time, same method, but instead of choosing moving mean, I'm going to choose the replace cell assignment method that we talked about before. So replace takes the last value that has been binned into the output raster. So that means that we can preference the values. So if I choose the high-res dataset and the low-res dataset, and what I'm going to do is I'm going to put the low-res one on top of the high-res dataset, so that the high-res dataset is the last dataset that is binned into the output raster. Now, when I run this with the replace option, you'll see that the high-res dataset completely replaces everything. There's no mean or anything, no blending done. It's just literally the value from that dataset. So let's do that. Let's choose replace and set our cell size again and run that. Let's see what that does. Okay, so it's added this one. Let's rename this so we know that this is the replace and this one is the mean. Okay, so now you can see the difference out here where this survey that's been executed out here, whilst that was blended sort of out in the previous version, it's now quite prominent, and the same with the values across this area here. Let's look at the profiles again. What I'm going to do is I'm going to generate the same profile across this one, so I can import the same profile. And as I switch between them, you'll notice that the replace method, the high resolution data, which is here and here, is much lower than the lower resolution, so lower in level than the low resolution or coarse resolution data. And so when I click on the mean, you can see that it's brought that back up higher, closer towards the other data set. So that proves that the mean is working and the replace method is working as well. So let's look now at the last method in the mosaicing processor. This is exactly the same as the previous method that we've looked at, except it simply asks for the raster inputs as an input folder or a series of files. So I specify an input folder, I specify the files that I want to, the extension of the file, so star dot, let's say, bill, and that will take all the bill files in the input folder and it will output them to one mosaic. So exactly the same settings as before, but instead of specifying rasters that are in memory, this is using rasters that are on disk or on file. So that's a very quick rundown of the mosaicing processor in RAMP. I hope this video has been useful to you.